Hello students, this video is the Unit 9 Lesson 4 lesson on special quadrilaterals. We talked about quadrilaterals earlier in this unit. A quadrilateral just has 4 sides, but there are special kinds of quadrilaterals that have specific properties. You can see the properties listed here, and there's also a quadrilateral family tree or a family diagram that's listed here. One quadrilateral that we're not really going to be talking about in this class is kites. However, all of the other types of parallelograms we will be talking about. And you can see that there's a relationship between a rectangle and a rhombus. Those two combine together to form a square. You can see that trapezoid is separate from parallelogram because they have different properties. Let's get into it. In the do now, it does say list the properties of a parallelogram and mark off the below diagram. Here's the diagram. It's of parallelogram ABCD. Pause the video, mark it up, and then see if you got it right. Okay, take a look at the things that we marked down here on the diagram. It's okay if you didn't mark everything, but take a moment now. You can pause the video and mark up your diagram in this way. They're color-coded, so you should be able to see what's going on here. Opposite angles of a parallelogram are congruent, like this angle and this angle are opposite of each other. This angle and this angle are opposite, so they're congruent. Opposite sides of a parallelogram are parallel. It's called a parallelogram because the opposite sides are parallel. So this and this are parallel. This and this are parallel. And then opposite sides of a parallelogram are also congruent. So parallel means they have the same slope, right? These are both horizontal lines. These are both vertical lines, or not vertical, but they're have a positive slope. Whereas the blue lines, the blue hash marks, indicate congruent pairs, right? The opposite sides of a parallelogram are congruent. Next in purple, I drew the diagonals here, and you can see that they bisect each other. In other words, this part of this diagonal is congruent to this part of the same diagonal, and this part of this diagonal is congruent to this same diagonal's part, okay? Last, in green, we said that these two angles next to each other, like angle A and angle B, if you want to say it like that, are supplementary. They equal 180 because they're consecutive. Consecutive angles of a parallelogram are supplementary. These are facts that you must know about parallelograms before we move on to the rest of the types of quadrilaterals. Now, you know all of these facts are true of any parallelogram. So, as I go forward on the other quadrilaterals, for example, this is a rectangle. A rectangle is a type of parallelogram. So, not only does it have these 5 properties, but it has its own special properties. Same thing with a rhombus. A rhombus is a type of parallelogram, so it has all of these 5 properties and other new ones. Squares are the same way. It's a type of parallelogram. Well, let me back up here. Let's do all the special quadrilaterals. One special thing about rectangles is that the diagonals are not just bisecting each other, as they are in any other parallelogram, but the diagonals are congruent. So, for example, ET and RC are the same measurement as each other. You can see that because in a parallelogram that looks like this, it's a little bit tilted, it's a little bit slanted, so that this diagonal is not going to be as long as this diagonal. However, a rectangle is straight up and down, right? It's got those right angles in it. So the diagonals have to be exactly the same measurement as each other. And the second piece of special information about this special quadrilateral, this rectangle, is that all interior angles are congruent. In other words, each of these angles are equal to each other, right? In a parallelogram, we know that opposite angles are congruent, but in a rectangle, it's special that all 4 angles are going to be equal to each other. Specifically, since all of the angles in a quadrilateral must add to 360, that means each of these individual angles is 360 over 4, which is 90. So that all interior angles are right angles follows from all interior angles are congruent. So that's the deal with rectangles. Rhombuses, or as some people say, rhombi, have other properties to them that are special. And here they are. One thing that you need to know about a rhombus is that in a rhombus, all sides are congruent. So each of these sides that are present are congruent to each other. They're the same measure. In a regular old parallelogram, we know that opposite sides are going to be congruent. In this case, we know that all sides are congruent. So we could also say that consecutive sides are congruent. That's another neat way to say it. And there's one more piece of information you need to know about rhombuses. The last thing that you need to know about a rhombus is that the diagonals are perpendicular. So any 2 diagonals that you draw inside of a rhombus are going to meet each other at this specific type of angle. That's a right angle. So we also know that their slopes are negative reciprocals. A very important piece of information is that the diagonals are perpendicular. And I tell you it's important because later on in this chapter, we're going to be trying to use coordinate proofs to try to prove that these specific quadrilaterals are rectangles, rhombuses, etc. If you can prove that the diagonals of a quadrilateral are perpendicular, it will instantly be a rhombus. So that's a specific important piece of information there. All right, now when you take a rectangle and a rhombus and you combine those properties together, surprise, surprise, you get a square because a rectangle has all right angles. That's pretty similar to a square. And a rhombus has all sides congruent. That's pretty similar to a square. So a square we can summarize in this way. We just say that a square has all properties of rectangles and rhombuses. So in short, all sides are congruent and all angles are congruent. All the other stuff is true as well. The diagonals are congruent, the diagonals are perpendicular, etc. But I didn't list them there because in basic, we can say the sides and angles are congruent. We also refer to a square as a so-called regular quadrilateral. Remember, regular means all the same size sides and all the same size angles. That's basically what we just said. All right, moving on. In this model problem, it tells you that in a rectangle, TRUE, which is, it spells out a specific word, diagonals TU and RE intersect at A. And they give the measurements of TA and RA and then ask you to find the length of the diagonal. Well, the first thing to do is draw this diagram, remembering that when you're drawing a quadrilateral, you follow these letters sequentially around the shape. So TRUE is going to look a little like this. Okay, you can see that this is rectangle TRUE, and you can see that the letters are named sequentially around the shape. All right, and it says TU, which is a diagonal, and RE, which is a diagonal, intersect at A. So we drew the two diagonals, and that intersection point we indicated as point A. Now let's label in the information that they gave us. All right, it tells us that TA is 10x minus 12, which is here. RA, which is from R to A, is 4x plus 24. Now what we need to do is identify the piece of information we know about this shape that can help us figure out what's going on as the relationship between 10x minus 12 and 4x plus 24. In this particular case, we know it's a rectangle, which means we know it's a parallelogram. So let's use two different facts to figure out the relationship between this piece here, TA, and this piece, which is RA. In a parallelogram, we know that the diagonals bisect each other. So in other words, I know that this piece here, which is T to A, is the same exact length as from A to U. And I also know that the piece from R to A is the same length as from A to E. Okay, parallelogram means diagonals bisect each other, they're labeled. In a rectangle, we know the diagonals are congruent. So that means I don't have to worry about doing one hash mark for these guys and two hash marks for these guys. The diagonals are congruent, which means these are going to be the same number of hash marks as these. So now that I've labeled everything that there is to know about this shape, in terms of the diagonals anyway, I can see that 10x minus 12 has two hash marks on it, and 4x plus 24 has two hash marks on it, which means they are congruent to each other, which means it would be perfectly mathematically accurate for me to set them equal to each other. Now I'm just going to solve this equation. It doesn't take a person in geometry to solve an algebraic equation, so I'm just going to fast forward to the end here. So now we see that x is equal to 6. The question is asking us to find the length of diagonal RE, so we know that diagonal RE is from here all the way down to here, and we now know the value of x, so we can start substituting it in to the different pieces of this rectangle. I can see that 4 times 6 is going to give me 24, plus 24 is 48, so the distance from R to A is 48. Well, look at the hash marks. There's 2 hash marks here and 2 hash marks here, which means if this piece of the diagonal is 48, this bottom piece must also be 48, which means that the length of the diagonal RE is 48 and 48. That's just 96. Now remember, we had to use a couple of pieces of information in order to set up our equation. So every time you come up to a question that's asking about a special quadrilateral, like a rectangle or a rhombus, or even a square, please make sure that you write down the information that you're using and use that to create an equation, solve the equation, and then solve the actual question. All right, I would do the check for understanding with you, but nice try. That's going to be in class. One piece of information that I'm going to give you is that when the diagonals of a rhombus are put together, they're perpendicular, so they form right triangles. So sometimes in questions, they'll ask you to use the Pythagorean theorem to find a missing part of a triangle formed by the diagonals of a rhombus. That seems like a lot, so let's actually take a look at what it's talking about. In this rhombus, which is called ABCD, it gives you the angle of DCA, which is this angle up here. And I highlighted that angle so you can see it a little bit better. Now it's asking you to find an angle of BCA and also the angle CBD. Let's take a look at what we do know. I've outlined this triangle, which is DC something, don't really know what this point is, But I know that it is a right triangle because of one fact that I know about rhombuses. So since I know that the diagonals are perpendicular, which means they form right angles, this angle is 90 degrees. That means I can find this angle pretty easily by using the Triangle Sum Theorem. And our old friend Triangle Sum Theorem comes through for us again. We know that the angle that's there, that missing angle, is 63 degrees. So we'll bring it in here. Okay. Now that we know that angle, we can start going around the going around the rhombus and filling in other angles that we didn't know and figure out the rest of the shape. Now take a look at this relationship that I've sketched in here. I know that the relationship between DC and AB is that these two sides are parallel, and I'm using a parallelogram fact, in which the two opposite sides of a parallelogram are parallel. Since these two sides are parallel, I know that there's a relationship between this angle, which is 63 degrees, and this angle down here, which turns out is also 63 degrees. That relationship, of course, is alternate interior angles. Now by now you should see a little bit of a pattern. If this angle is 63, we're going to be able to figure out this angle pretty easily because this angle is also a right angle. And all of these triangles have kind of a similar thing going on. As a matter of fact, they're not just similar to each other. All of these right triangles are congruent to each other. And we know that because this side and this side, for example, AD and AB, are congruent. All sides are congruent because, guess what? It's a rhombus. That's a fact about rhombuses. So once we know the angles of one of the triangles, we can fill out all the angles in all of the other triangles. The small angle is going to turn up being 27, the large angle is going to turn up being 63, and that works for every single angle. Now we can go about answering the questions. The first one asks us what the measure of angle BCA is. Well, from B to C to A is this angle over here, and that angle must just be 27. Next it asks for angle CBD, so from C down to B, up to D, that angle is just 63 degrees. Now think about all of the measurements that we found in this rhombus. We were able to find those measurements just by stuff that we already knew, the Triangle Sum Theorem and alternate interior angles, and special properties of these special quadrilaterals. The fact that diagonals are perpendicular in a rhombus, the fact that opposite sides are parallel in a parallelogram, and the fact that all sides are congruent in a rhombus. Using this information, we're able to come up with the rest of the pieces of the information in the shape. Let's move on to the last model problem, which is down here. It tells us that RSTU is a square with these diagonals that intersect at W. It asks us to find the angle WUR and angle TWS. Well, by now you know, we should start writing down the things that we know about the shape first, and then label stuff that is missing. Well, the first thing I know is that all angles are congruent. That means they are all right angles. Another thing that I know in a square is that all sides are congruent. That gives me an important insight. Let's take this triangle, for example. This triangle is triangle RTS. This is a right triangle. And I also know that it is an isosceles right triangle because these two sides are congruent. If it's an isosceles right triangle, that means one angle is 90, and the other two angles, the base angles, must be 45 and 45. 90 plus 45 plus 45 is equal to 180, and these angles must be the same. So let's mark that in. As a matter of fact, we can extend that to all of the other angles that are created by cutting a 90-degree angle in half. If this is 45 degrees, this must be 45 degrees, and so on and so forth around the shape, which is very helpful to us because the first angle that we're trying to find is angle WUR. From W to U to R, now we know is 45 degrees. The other angle we have to find is angle TWS, and TWS is sort of inside, like in where these two diagonals intersect. Well, we need one more rule about shapes, specifically about special quadrilaterals, to help us find this angle. And you should remember that a square is a type of rhombus, and in a rhombus, the diagonals are perpendicular. So that means if these two diagonals are perpendicular, then angle TWS is going to have to end up being a right angle. So again, what we did here was we identified the pieces of information that we knew about this special type of quadrilateral, a square. We applied them to try to put labels around the shape, and then we answer the question based on the information that we were given. There was no equation to set up for this one, but if there were an equation to set up for this one, we just used the facts that we wrote down in order to make that equation possible. All right, the rest of the lesson is checked for understanding and problem set, so that means we've reached the end of the video. This was the video on Unit 9, Lesson 4 for special quadrilaterals. parallelograms, rhombuses, rectangles, and squares specifically. Good luck studying.